Okay, so for 3-4, we're going to take a look at these exponential and logarithmic equations now. So we're going to use the properties for from both sections 2 and 3 to manipulate these. So, if I can find something to write with. A lot of this will just be solving equations. Now, ones like this, you got basically 3 different techniques you can use. Something basic like this where you can blatantly see that they share a common base. Well, 2 to the x, 2 is blatantly your base. For 512, that's 2 to what power? To the 9th. And yes, I would recommend knowing all the way up to about 2 to the 10th or so. Okay? Off the top of your head. And then I wrote 10 because I said 10. So, 2 to the 9th. So x is what? 9. Okay? Those ones are fairly easy if you're comfortable with those exponents. C, what's the base going to be there? 5. So if 1/5 is going to be 5 to the negative first, and since there's an x there, I'm going to make it negative x. 125 is 5 to the third. So x is equal to negative 3. These are both that one-to-one property for solving. You're basically making it the same on each side of the equal sign, same base. ln of x equals negative 8. For this one, this is currently in the logarithmic form. So the x is essentially trapped inside with the log. Well, you can't divide by a log. It doesn't make any sense. So what you have to do is change its form from logarithmic to exponential. Okay, so what's your base in this case? E. So what I end up with is e to the what? Negative 8. So I'm going to take what's on the other side here, put it with the e. That's going to be equal to x. So you get x is equal to e to the negative 8. If they're asking for exact answer or they're not specifying, that's actually sufficient. Okay? If they're asking for decimal, then plug it in your calculator. So on this one I could use some basic algebraic properties and go back to the one-to-one. Because if I move over the ln of x, if I add it to both sides, I have ln of 5 equals ln of x. So what's x? 5. That's that one-to-one property again. This one's in what form? Exponential form. So this is an exponential form. To get the x out of the exponent, I could change it to what? Logarithmic form. So what's your base? E. So the logarithmic form you're going to use is what? Natural log. So it's ln of what? Equals x. And for exact answer, you're actually done at that point. If you wanted the decimal, plug it in the calculator. For the next one, what form are we in? Change it to exponential. What's your base? Raised to the equals. Now that one I would change. 10 to the negative seconds, the same as what fraction? 1 over 100. Questions on those? That's the primary thing this section talks about, is those 3 methods to solve. Using one-to-one properties, changing exponential to logarithmic, changing logarithmic to exponential. Okay? Those are your main 3 techniques. So if I have something like this, what property would I use to solve as a first step to solve the first one? One-to-one. You have e for both bases, so I can just take both exponents and set them equal. Then what? Yeah. Add the x squared. Because you have an x squared and you have an x, you're not going to be able to just solve for x directly. You have to create the quadratic. I wouldn't bother with quad program, because quite frankly, this factors into what? Yeah, x plus 3 and x plus 2. So then your x values are and negative 2. What about for the next one? Divide by 4 first so you can get the exponential by itself. So if I divide by 4, I'm going to get 3 to the x equals 16. So divide by the 4 first. Now, is there any way I can do one-to-one on this? No, because 3 and 64 don't have a common base to work with. But you can do what? Change the form to logarithmic. So you're going to have log base what? Log base 3. Whatever the base is here is going to be the base down here. Of what? 16. You got to move the 16 to be over with that base when you change it. Equals x. Now it does ask you to round to 3 decimals, so this one I would plug into the calculator, giving me what? Remember, you can just do natural log of 16 divided by what? Natural log of 3. What do you get? 2.524. Anybody else? Okay. Now some of them you got to do might have to do a couple steps before you can actually use one of those three properties, something like this. What would I actually do first here? Subtract the 5 from both sides. So you have negative 3 e to the x equals negative 3. Divided by negative 3. So I get e to the x is equal to 1. Now if you want to, you don't even have to use those three properties, because if e to the x equals 1, what does x have to be? 0. If you wanted to, you could change it to ln of 1 equals x, which is also 0. Questions so far? Okay. For example, 4. Again, a few pieces to move around. What would I start with? Subtract the 4. So I have 6 times 2 to the t plus 5 is equal to what? 7. Then divided by 6. I get 2 to the t plus 5 is equal to 7, 6. I'm going to leave it that way. I want to try to avoid all decimals until my very final step. What would be next? Switch it to log form. It's going to be log base what? 2 of equals t plus 5. So log base 2 of 7, 6 equals t plus 5. Subtract 5. So when I subtract 5, I'm honestly going to move it to the front, just so I don't think that it's included with the 7/6. Does ask for the decimal approximation, so punch in a calculator. What do you get? Anybody else?
Yep.
Negative 4.78? Or 778, right? Yeah. Okay, let's do one more. E to the 2x minus 7e to the x plus 12 equals 0. Any ideas here? Well, if I subtract 12, then I'm going to have to deal with e to the 2x and e to the x. Now, can I combine those together in any way? Yeah, they won't go together. Now, notice the format. If I change the way this e looks a little bit, e to the 2x is the same as e to the x raised to the what? To the second. Then if I minus 7 times e to the x plus 12, what does that look a lot like? Quadratic. It's a very odd quadratic, but it is a quadratic. So you can solve this using quad, or you could just factor it. Instead of having x squared minus 7x plus 12, you have e to the x. So when I go to factor this, what's going to be first in both of these? E to the x. Okay, now you want to multiply to be positive 12, add up to be negative 7, so what are those going to be? Minus 4, minus 3, both equal to 0. Then what? Set each of them equal to 0 and solve, so e to the x minus 4, e to the x minus 3. So I have e to the x is equal to 4, and e to the x is equal to 3. I still got to find x. Change it to log form. So what's the log form going to look like here? And equals x. If you're looking for exact answers, those would be done. If you're looking for approximations to 3 decimals, punch them in the calculator. Questions on any of it? Yeah. I didn't actually take it out. I moved it into the squared part, right? So this essentially what I'm doing here is u squared minus 7u plus 12 equals 0. Except for the u stands for what? e to the x. Okay. The rest of the time is yours today. Make use of it. Quiz tomorrow is one side of one sheet, 6 problems. So you should have plenty of time to get it done.